Okay, hello everyone. So today we are having with us Vaibhav, and today is the first of the mock interview, and it would be a short mock interview, not a 45 minute, but less than that. So Vaibhav, first introduce yourself.
Thanks, Komal. So my name is Vaibhav, and I did my bachelor's in computer science and engineering. So currently, I'm working as an embedded software developer since like past 3 or 4 months at Texas Instruments. So yeah, I'll keep it short and let's kind of straight jump to the interview.
Yeah,
I am going to start with this. I think it's taking a couple of minutes here and there. Okay, I think so. It's not working. The platform is kind of lagging out. So why don't you give me a problem from, let's say, lead code, and I'll probably do that, and we can get over with it. That could be fine if it's fine with you.
yeah, it's fine with me. Then I can share you Google Doc link that you can open.
There is a problem hearing your voice, so let me see.
I guess there is just lagging because of the platforms which are there.
Correct, correct. If you have the question at your end, you can probably share me, and on the
Yeah,
chat,
I'm
maybe
just
I can
sharing the
just.
link.
Okay.
Means Google Doc link.
Yeah, okay, that will also do fine. You can share me in the Zoom chat. That will be fine.
Okay, I've sent. You can open that.
Yeah, yeah, you can probably give me a question here, and then I can probably start with it.
Okay.
So you have to kind of provide me the edit access as well, else I won't be able to write it. So you can reshare the link maybe and provide me the edit
I'll
access. That would do
directly
fine.
provide you. You can just refresh it.
Yeah, okay. Yeah, it's all good. Yeah. And
I'm just giving you the question. So as it would be a short interview, so that's why I'm providing with the question which could be solved in this much time.
okay. Yeah.
So please can that on the stop. So yeah, this is the question.
Okay. Okay, so uh, let's say what I'm going to do is I'm going to simply increase the font. Is that fine?
Yeah, no issues.
Font size. Yeah.
But it is already clearly visible. If you want to, then it's all right.
Okay, sure. So uh, the question is as follows. So we are given a string and we have to kind of find the length of the longest substring without repeating characters. So what I can resonate with the problem statement is that let's say I need to find a very let's say I need to find a particular substring in which all the characters will be unique. So that's what the statement is without repeating characters. Now, with respect to examples, so we have, let's say at the very first one, we have um, ABC, a bunch of ABCs, and then followed by double Bs, right? So the output is three because they have mentioned and the answer could be ABC. But I could also say that, hey, the answer could be this ABC or the answer could be BCA as well, right? So I think so. These are few of the multiple answers. And the good thing about this is they are not requiring the string itself, but they are requiring the length of it. So we don't need to be worrying about if the answer could be ABC or BCA. In
Yes.
this case, I think so. In this case, I think so. B is the only one because I can't take a bunch of B's because that's repetitive. Now, in this case, we have let's say I could have PW, then I could have had WK, right? So WK is one of them. Hence, the answer is three. Okay. Okay. Also, it's also mentioned that, okay, we cannot have something like PWKE because that's going to be a subsequence, right? And not a substring. Substring is more of like contiguous segment, not broken down, right? Okay. So what I am thinking of as a solution is that maybe I can probably run two for loops, right? I can run two for loops. So this is what I am thinking right now. So the very first for loop will be there, followed by a nested for loop. And with help of this, I can probably generate substrings and check if they are unique. I mean, if they have uh, unique characters that will add to the answer. And if that's the case, then if that's the case, then I'll if so, then I'll update the max length variable I could have, right? So this is one approach. So can I begin with this?
And what would be the time complexity and space complexity for this approach?
So essentially, what will happen here is since I have two for loops, so the time complexity for this would be probably um, big O of n square, kind of n square, because when I run through all of these things, I can probably check at any point of a time. So let's say I'm starting from a particular substring. Let's say I'm starting from P. So from P, I can at max go till W. I cannot go apart, like I cannot go far from this because if I go here, I know anything starting from P is already having two W's, which is not satisfactory, right? So I can probably check for uniqueness in the second for loop itself. I don't need another for loop for that. So that's why I'm saying that the time complexity would be big O of n square, wherein I can just simply write like this. And the space complexity uh, would actually be big O of n, I guess. The reason being, I will be having a set data structure. Let's say up here, I'll be having a set data structure, which is going to it's going to kind of check for that if the element has been visited or not. So in the worst case, this set data structure could contain n elements at max. So that's what the time and space complexity for this algorithm would look like.
Uh, what about if I give you constraint in such a manner that this much time complexity can give you really? Can you
Could you
optimize
repeat?
it? Can you optimize it more?
Should I optimize in terms of space or time
Time.
or both? Okay. So what I see here is that in this case, let's say I'm talking about A, B, C, right? So what I'll try to do is I'll try to keep window, right? I'll try to keep a window of some length, which is not fixed here. So this could be a problem or a variation for uh, sliding window technique. But in sliding window technique, we generally see that, hey, we have a very fixed length in the, so in the worst case, I could have a sliding window of length 2. But what if all the characters were unique? So I could have a sliding window length of the entire length of the string, which is, let's say, n. So what I can do is, yeah, I can probably use 2 pointers and the sliding window approach to kind of maintain that, hey, uh, are all the characters in this window unique or not? If that's the case, then I'll update the answer. Else, I won't update the answer and I'll move forward. That's something I could do.
Okay. And then what would be the time complexity for the same?
So for the time complexity for it would be that from n square, we can probably boil it down to close to big O of n. And the space complexity part would be probably still big O of n, because again, I need a data structure which will make sure that, hey, all the characters are unique or not. So yeah.
Okay. So you can code this solution. The
Okay.
option.
So yeah, so I'll be using Python 3 to code the solution. Now, let's assume that we had a helper function, solve, and we were given a string variable. And is that the only thing which we need, or anything else do you want to provide here
Mm,
for the argument?
Only
Is string the only thing which we need, or anything else?
only string.
Okay, only string, right? So we have the helper function, and we have to kind of write the code here, right? Uh, so basically, the very first thing I would like to break this problem here. So the very first thing I would like to do is um, keep track of start and end variables, wherein my probably start and end are going to denote the sliding window, right? And at any point of a time, if I want the length of the sliding window, that would be given by end minus start by 2. End minus start plus 1, not by 2. So that's my bad. Okay. Now, yeah, let's begin. So before even I go forward, I need to keep track of a max length variable, which is initially, I guess, 1, because, hey, if I don't even do the process, I know for a fact my by default, by default, uh, the max length will be 1. So instead of having it, yeah, so instead of having the value as 0, it makes a lot of sense to have the value as 1. Great. Now my start will be one end of the uh, sliding windows pointers, and end will be the other end. So the end will be kind of running with the for loop. So let's say the numbers are like this, or let's say in this case we have a string, right? So let's say my start is here and my end is here. So in this case, the sliding window is represented by this start and end, right? So probably this is what it would look like. By the way, this start and end would be not in the string, so it would be somewhere like this. So let's say my start is at S and my end is at D. So the sliding window length is this. It's going to be of length, I guess, 4, right? So this is what it would look like at any point of a time. So I also need to keep track of a yeah, and also need to keep track of character set. So what I'm declaring right now is a character set, which I'm going to simply say unique characters, because that will make a lot of sense. And it's going to be simply a set in Python. Now let's begin with the for loop. So for end in range, length of the string. Also, I could have length of the string at any point of a time. But what I would do is for a neat approach, I would do n is equivalent to the length of string, and then probably have n here itself. So what for end and range is probably an equivalent for what we see in other programming languages. So it would be something like this, right? So this is an equivalent for Python. That's it.
Yeah.
So just a little info on this part. Now, for Indian range n, what I will do is I will say that, hey, if the current character, let's say I am accessing this string ABC, right? So yeah, ABC. So I know that, hey, AI, when I'm at this character A, right, end is pointing to this character A, end is at the zeroth index, I'm at A. So I know that I have to put this A in unique characters for sure, right? Then I have to put in B, then I have to put in C. But what if I encounter an A again, right? Let's keep it short. What if I encounter an A again? In that case, I have to move my start from this index, which is at the zeroth index, to this index. So my start will go from 0 to 2. This is what my start will go. And how will I be able to manipulate the start index? Well, I'll just simply use a while loop inside of this for loop. So that would be, what would I call, nested while loop inside of a for loop. So let's just quickly do that. In here, I can simply say that unique characters. Um, so let's say, okay, so what I see here is instead of blindly putting in a character, let's say instead of blindly putting in a character A, firstly, I'll check that, okay, while my A is not in the unique characters. Yeah, that's what I'm looking forward to. So probably, let's say I had a bunch of A's like this, right? So in that case, if I blindly write a statement like, hey, I want to put in, hey, I want to add the character in the set, then that will never make sense, because I need to firstly make sure that my unique characters is actually unique, like it has actually unique set, right? So I'll say here, while, um, yeah, while my current character, which is string of end in unique characters, so I'll probably put a little bracket here, while string of end in unique characters. In that case, what I can do is I can probably get rid of that. So unique characters. Okay. Let me think of one thing here. So let's say I had the string maybe C, right? A followed by A. So what I could do here is in my set, I'll be having A, then I'll be having B, then I'll be having C. Then once I see that the current character A is in the set, then automatically my start will go forward, right? Mm, okay. Mm, okay. So unique characters, then I'll go forward. Yeah, makes sense. Yeah, makes sense. So my bad. So in this case, while this is happening, then I'll say unique characters dot remove uh, this value. So I'll be removing
So
the value at the,
are you
yeah.
taking that input as string?
Yeah, actually I took an input as string. So should I take it as S?
If there could be any error because string is also a data type only. That's why.
Actually, in Python, we have str as the data type, so it's going to be fine. But again,
Okay, then it's
a few
allowed.
hours. Okay, yeah. So in Python, we don't have anything as such string. We deal with str. So yeah, get rid of that. So unique characters dot remove a string of start. Yes. Okay. So it's saying something like this, that, hey, I was currently accessing. Yeah. So initially what will happen is that my string of end, which is A, is not in unique characters, right? It's not in unique characters. So it's not never going to go in the while loop. So it's going to be added in the unique characters, which I am going to add like this. Dot add and then string of end. Now the thing is that, hey, right now what happened was A got added. Now I'm at B, right? So here at B, I'll be saying that, okay, while B in unique characters, no, B is not in unique characters. So it will straight away jump to this line and add B. Now, when I'm saying C, so again, C will be added at this line, right? But when I get to A, like, okay, hey, A is in unique characters, right? So while A in unique characters dot remove string of start. Why am I not removing string of end? Because I want to move my start forward, not end, right? End will be fixed. End is moving forward with the for loop. So in this case, I'll say that, okay, unique characters dot remove string of start. So maybe I can remove A, right? So A will be removed from a unique character. So unique characters is actually pointing, like unique characters is actually having BC itself. Once that's done, again, it will come to the while loop. It will say, while A in unique characters. Now the A is not in unique characters. Hence, I'll go here, add A here, and that should be it. In this case itself, I can update my max length as follows. So my max length would be updated as maximum of my previous max length. We have a little spelling mistake here. So previous max length, and the current length would be denoted by end minus start plus one. This is what my window length is. I think so. Once that's done, I can probably return my max length value. As a part of the next step, what I'll do is I will probably try run this for, let's say, give an example, ABC, ABC, BB, right? So what's happening? Let's see. Let's go over this real quick. So what's my unique character set going to hold and what it's not going to hold? We'll see through that. So also my start is at 0 initially, end is also at 0. So this is what the working would look like. So initially end is at 0. Notice my start is not moving, end is moving with the for loop, right? Also, I think so I made a minor mistake here. While string of end in unique characters, I'm removing string of start, but apart from that, I think so I have to also increase start as well. That will make a lot of sense. Now, post that, so let's say end, right? So I'm at A. I'm saying that, okay, A is not in unique characters, so simply put in A. I'm at B. B is not in unique characters, so put in B. I'm at C. So C is not in unique characters. I can put in C, right? Also, my max length will be updated as follows, right? So max length won't be any problematic thing for us. I'm kind of denoting how the values are changing in unique characters and how start and end is changing. End is, by the way, currently at 0, 1, 2, 3. So right now, end is at 3. At the third index, the value is A. Now I know this while loop will be quite effective here. It's saying while A in unique characters. Yeah, it's there, right? So I'm saying unique characters dot remove string of start. Start is still at 0. So it's going to remove this value A from this set. So A gets removed. Again, this while loop checks. Start, by the way, comes to 1, right? Because there was an increment which I forgot to put earlier. Now, we have, again, while A in unique characters, no, A is not there. So I go out of the loop and I say unique characters dot add string of end, which is particularly A itself. So A gets added back. And again, when I'm looking at the next index, so end comes at 4. So at the fourth index, we have value B. So again, it's saying while B in unique characters, yeah, it's there. So I'll get rid of that and start will move forward, right? Now, again, while B in unique characters, no, it's not there. So as a part of the next step, what I'll do is I'll add it to the unique characters. So C, A, and then B. As you remember, I also mentioned that ABC is one of the answers and CAB is also one of the answers. We can kind of see from this set itself that, hey, CAB is also one of the answers, which will be updated here, right? But again, both of them have length 3, so that's absolutely fine. So again, what I can do as a part of the next step is my bad, I will increase end. So end is going to be at, I guess, fifth index, which is this 0, 1, 2, 3, 4. Again, I'll be saying that, hey, while C in unique characters, yeah, it's there. So remove it, right? But what am I removing? I'm removing the value in the string at the start index, which is 2. So 0, 1, 2. Yeah, I'm removing C, right? So C gets removed and that's pretty much it. Now, again, while C in unique characters, no, it's not there. So I'll probably say that, hey, um, start will be increased, by the way. I'll add C to the unique character. So probably my C gets added. And that's the real reason we got initially ABC as the representation. And then we got something like a CAB or a BCA, right? And then right now we are at ABC, correct? So this is how it's kind of working. And now what will happen is that end will be at the sixth index, which is probably this B, right? Now 0, 1, 2, 3, 4, 5, 6. Yeah. So again, it will say that, hey, while B in the unique characters, yeah, it's there. So remove the character at the start index, which is 0, 1, 2, 3. So I'm removing A right now. Notice carefully, I'm removing A. So A gets removed. Again, it's saying while B in the unique characters, yeah, it's still there. So again, I'll remove it. So I'll remove the value at the fourth index, 0, 1, 2, 3, 4. Yeah, I'll remove this B. So this B gets removed. Now again, I'm saying that, hey, start gets incremented forward. While B in unique characters, no, it's not there. So what I can do is I can say that, hey, let's just put in B here. So right now, what I am referring to as a substring is the CB. But yeah, this is not the maximum length, but yeah, this is one of the substrings. Now again, this will go on until we reach the very end, which will be having B itself. So this is what the working would look like.
Okay. Yeah, it looks fine. And you have explained about the trial the same.
Could you repeat?
Yeah, it looks fine, and even it's good. You have explained the trial run also for the same, and that test case itself has various other test cases which I wanted to give you, so it's fine.
Okay.
How much time? After. So yeah,
Yeah, I believe so.
as
It's
we
20
have
minutes. Yeah.
time, uh, how many minutes?
Yeah, I think so. It is probably 20 minutes past 20, 25 minutes.
Okay, so we still have times. We can go with the second question as well.
Yeah.
I'm just giving you that second question.
Okay.
And if possible, can you turn on your camera as well? Because
Yeah. On Zoom, I can, right? So I will do that.
in that sense, I'm saying because of lagging, if there is an issue, then that's fine.
Okay.
So I have pasted the second question as well.
Hmm. Okay. So, okay. So you are given an M cross N grid. Probably do that. Um, so there is an M cross N grid wherein each cell can have one of three values, right? So, okay. So there's a grid which is a matrix itself, end of the day, and 0 is representing an empty cell. 1 is representing a fresh orange, and 2 is representing a rotten orange. Okay. Every minute, any fresh orange that is four directionally adjacent to a rotten orange becomes rotten. Okay. Any orange, any fresh orange. So every minute, right? So that is four directionally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has fresh orange. If this is impossible, return a negative one. Okay. The minimum number of minutes that must elapse until no cell has fresh orange. If this is impossible, return a negative one, right? Okay. Okay. What I am thinking of is, so we had a rotten orange here, and in the first minute, it will probably make the other three oranges rotten, right? Okay, so diagonally, it's not possible. Four directional, okay. And then this will rotten this guy. This will be rottening that guy. This will be rotten and that will, okay. So that's one, two, it's 1, 2, 3, 4, 4 minutes. Okay. 1, 2, 3, 4. Okay. Hmm. And then we have this example as well for which the diagram is not given. So 2 is probably fresh orange, right? Or it's rotten. Okay, it's a rotten orange. So 2 is going to infect this one. Okay, so 2 1 1 0 1 1 1 0 1, right? So we have 2. So we have 2 1 1 0 1 1 and 1 0 1, right? If I'm not mistaken. Yeah. So 2 will rotten this one. This one will rotten this one and this one. That's 2 minutes, 3 minutes, 4 minutes. But I cannot rotten all the oranges. Hence, the answer will be -1, right? Because yeah, I can't rotten all of them. In this
Yeah.
case, it's 0 2. So yeah.
Yeah.
Okay. In this case, it's 0 2. So the output is 0 because all the oranges are rotten at the very beginning itself. Hmm. Okay, so what I'm thinking of is a very basic BFS algorithm. Uh, the reason I'm going for a BFS is because I have to spread in terms of direction instead of going in depth. Um, this is not really a DFS, but this is BFS, right? So breadth first search is something I'll be looking forward to and not depth first search. So the idea would be to maintain a queue. Again, queue is a data structure which is probably having front and rear, and it's more like first in, first out, right? Yeah, the first value which goes in is the first one out, right? So yeah, I'll be using queue help, using queue, and then probably I'll be having, let's say, a particular rotten orange in my queue, right? But the best thing to do here is that there could be a lot of rotten oranges inside of my matrix, right? It's not that there's only one rotten orange, but there could be a possibility that we have a lot of rotten oranges. Yeah. So two can be, let's say the rotten orange could be this one as well, the corner one, right? This value could be 2 as well, right? So in that case, I have to initially take in all the rotten oranges in my queue. And from that point onwards, I have to go four directionally, right? As mentioned in the problem that it's going to rotten all the fresh oranges four directionally, right? I mean, that is four directionally adjacent to the rotten orange, right? So yeah, I can probably start with that. By the way, the algorithm which I have in my mind is probably known as multi-source breadth first search algorithm. Now, why is it known as why is it not simply known as breadth first? Because breadth first search, because here I have multiple sources, right? Okay, my bad. Here I have multiple sources to start from. Here I could have multiple rotten oranges to start from. So yeah, so the time complexity for this would be rounding down to m cross n, wherein, give me 1 second. Yeah, the time complexity for this would be rounding off to big O of m cross n. And I have to have a space complexity of, let's say, m cross n as well, just to keep track of all the oranges which have already been rotten or visited. So yeah, this is something I have in my mind.
Okay. Yeah, you can go ahead with the coding for the same because
Okay,
yes, it requires multi-source DFS only. I want to see your code now.
okay. So Python 3 is something I'll be using here as the previous one itself. And yeah, so let's say I had a solve function, not solver function. And can I assume the input to be only grid itself?
Yeah.
Okay. So the very first thing I'll do is I'll denote n as the number of rows and m as the number of columns. So that should be pretty much easier for you to understand whenever I use n and m. So I can simply say n is going to be the length of the grid and then followed by which is going to be the length of grid of 0. So that's going to make a lot of sense. Now, um, I'll be using a queue here, and to make use of queue, I have to kind of import something from the collections module. Else, I will have to declare a class DQ, which will probably be initialized using doubly linked list. Yeah, doubly linked list, or yeah, doubly linked list or a single linked list. So should I import it or should I create a class for DQ?
Uh, you can import for time being.
Yeah, could you repeat?
You can import for time being. You
Okay.
can import.
So so the DQ thing is provided in the collections. So from collections, import DQ. So DQ has few of the important functionalities I'll use. The very basic one which I'm going to use is pop left, which kind of removes the first element in a big of one time, and it's not going to take big of n time, right? So initially I have Q initialized as DQ, and I'll probably loop here in the matrix, which is the grid. So for I in range n, and then I can probably say for j in range m. And in this case itself, I can probably point out that, hey, if my grid of I and j is equivalent to 2, which means it's a rotten orange. My bad, it's a rotten orange. In that case, I can probably take it inside of my queue. So queue dot append, I'll be having something like I and j, which is the coordinate, right? This is what my starting point would look like. Now, what I could also do is instead of having, like, apart from having I and j, I could also have a value 0. So how is this value represented? So the value inside of Q is represented as follows: the row number, the column number, and the starting minute, which is 0, right? So this is nothing but the starting minute. So if I'm starting from, okay, so if I'm starting from, yeah, starting minute, right? So if I'm starting from a particular cell, then the time at that point is 0. So that would probably help me in the BFS algorithm. So when I go to a next rotten orange, I would probably go to, let's say, a next cell. Let's say it could be row plus one column, right? So that's a new cell. I'm going to rotten that fresh orange, but at that point of a time, the time would be starting minutes plus one. Yeah, I would have that, right? So yeah, that's it. Also for the Zoom call, I think so we have 1 minute left. So should I probably relaunch this thing and get back on quickly?
Okay. Yeah, you can relaunch.
Yeah, I would probably stop sharing and then I'll relaunch this.
Okay.
You can join the meet again.
Okay. That's all.
I will probably put out the link chat, I mean, link in the Google Docs itself, right? So you can take it from
Yeah,
Google Docs.
that's
You don't have to open up WhatsApp there. Yeah.
okay. Mm, mm. Yeah, you can continue.
Yeah, you can hear me, right?
Yeah.
Okay, great. So I'll get rid of this. Okay, so this is what the ideal representation is. The row and the column and the starting minute, which is by default 0, so I don't need to be worrying about what this value would be. Um, Now, as a part of the next step, I need to keep track of if the current if the current location in the grid, or if the current fresh orange has been brought in earlier or not, right? So I could visit fresh orange twice, more than twice. So that's something I have to keep track of. And I'm going to do that, let's say, with the help of a visited array or a visited matrix. That would probably help me out. But because, see, I could probably use the grid itself to modify the values. So in the grid itself, when I see that, hey, this one has been rotten, so I'll put it as 2, right? This one has been rotten, I'll put it as 2. But that would probably violate the grid itself. The original grid will be lost. What if I need the grid for further purposes, further operations, right? That's the that's the main reason I'm using a space extra of big of m and m cross n. But if I'm allowed to change the grid itself, then the space would boil down to big of 1, which is not ideal to do because I want the original data structure to be as it is, right? Okay, so what I will quickly do is I will probably align this and I'll keep track of a visited set. So this visited could be denoted by 0, I in range m, for j in range. And so what this has done is this has created a visited, not set, but a grid or a visited matrix of size m cross n itself. So all of the values initially are probably 0, as we can see. Okay. Now I can probably start with the BFS algorithm, right? And how will that go about? Well, I can simply say for I in range n, followed by for j in range m. What I will say is that, okay, I don't think so. I need to do this, right? Yeah, I don't need to do this because I already have the starting points in my queue, right? So I can probably straight away begin from that and onwards. Also, I need to keep track of the maximum time which has been spent, which is initially 0. What if all the oranges in the queue are rotten? I mean, in the matrix already are rotten, so max time will be by default 0. So yeah, so this is how I'll begin. So while my while q is kind of equivalent to while length of q is greater than 0, right? This is equivalent to this. So yeah, while q kind of works fine. So when I open up or when I take the values from Q, what I'll be having is a particular row number, a particular column number, and a particular. Okay, so what I can say is I will be having a particular X coordinate, a Y coordinate, and the current minute. And that's going to be given by Q dot pop left. Yeah, this is one of the most useful in operations for DQ, which I have imported up here. As you can see from collections, import DQ. So yeah, that's one of the most important things. Okay, so right now I am at X, Y, and then the current minute I do have it, right? So what I will say is that my max time is going to be the maximum of my current minute and whatever my previous max time was, right? This is what the orientation would look like. Now, from the current cell, um, I can go from the current cell. I have to I have to go in four directions. But again, when I'm at a current cell, the four directions value could be out of bound as well, or it could be that the orange is already rotten. So I don't need to revisit that, right? Yeah.
Yes.
Could you repeat?
Could you again ask? I just lost. Should I again repeat?
Should I repeat this?
Yeah, yeah.
Okay. So also a little correction here. This visited, I'm going to take it and I'll place it right here. I'll tell you why. So this visited kind of keeps track of all the nodes which are visited, right? Now think about this. Think about this. When I'm taking some values in the queue, right? When I'm taking some coordinates in the queue, I'm actually visiting them, right? So apart from adding them to the queue, I will also say that, okay, I'll add it to my visited as well. So I can say visited of this current cell, which is ij, will be stated as 1, which states that, hey, it's visited. That's it. So this is a really important step, which I tend to miss out right now. Now, what I'm doing here is I'm keeping track of a max time variable, which is going to, end of the day, it's going to be giving me the maximum minutes required to rotten all the oranges. Now, this while queue is kind of making sure that, hey, while my queue is having some values, take it from the queue and process it. That's what my while queue is doing. Now, right now, what I'm doing is I am tuple unpacking the queue. So when I'm saying queue dot pop left, so in my queue, the values are stored in this format, right? Row, column, and starting minute. So I'm taking the very first value in the queue right now. That's pretty much it. So I'm saying that the row is nothing but the x coordinate. Let's say my column is nothing but the y coordinate, and my starting minute, I'm generalizing it as the current minute. That's it. Now, once I have the coordinates x and y, I can simply say that from the current cell, which is x comma y, I will go in four directions and then I'll move accordingly. Does that make sense?
Yeah. Yeah, it makes sense.
Okay. Now, since I'm moving in four directions, so I have to keep track of the directions thing. So let's say I'm at x comma y, so I can move to the next row. That would be a +1, but the same column. I can move to the previous row. That will be a -1, but the same column. I can move to the next column, but the same row. So same row, but next column. And I can also move to the previous column, which is going to be same row, but previous column, which is -1. So this is how I have declared the directions array, right? Now I can say for, let's say I in range 4. So why am I looping 4 times? Because I'm going to access these direction values and add it to the x and y. So right now for I in range 4, uh, what is my new x coordinate? My new x coordinate would be the current x coordinate plus the value in directions at this x, right? So to this, always this +1, -1, 0, and 0 will be added, right? So this will be nothing but directions of I of 0. It's really important to know this. Now my new y coordinate would be probably y plus uh, directions of I of 1, right? Now, once I have new x and new y, I need to check that, okay, these coordinates, the new coordinate, new x and new y are inbound, right? So a very basic way to check is that, okay, if my new x is inbound of rows and my new y is again inbound of the columns. So this is how I check. And I have to also make sure that the visited of new x and new y is equivalent to 0, which means this coordinate has not been visited. That's it. This is what the real meaning for this is. This cell has not been visited. But I also have to visit it if the value in the grid at new x and new y is 1, which means it's a fresh orange. So notice carefully. What I'm having here is a coordinate cell for a rotten orange. From this rotten orange, I'm saying, okay, this is the new coordinate, new x and new y. That's it. Now I'm saying if the new x and new y, this kind of makes sure that I am inbound of the grid. I'm inbound of the grid. Once that's done, I'm saying that, okay, this is not visited as well, right? Okay, great. This is also one check. Third check is that, yeah, the third check is that in the grid, that cell is having a fresh orange, not a rotten orange. I cannot have a value like 2. 2 means it's already rotten, so don't need to visit it. 0 means there is no orange. 1 means it's a fresh orange, so I have to visit it, right? So in this case, if that's something which is happening, then in that case, I'm saying q dot append. Probably notice carefully, I'll be having new x here, the new y value, and the time here would be whatever my current minute was. So from this current minute, let's say my current minute is 100. So to go from current minute 100 to the neighboring cell new x, new y, it will take one more minute, which will be 100 plus 1. So this will be current minute plus 1, right? What I will also do is I will probably take all of this and decrease this in font. It will make a lot of sense. Yeah, so this makes a lot of sense. I hope so this is readable at your end, right?
Yeah, it is.
Okay. So q dot append new x, new y, current minute plus 1. And I will also say that, okay, hey, this cell has been visited. So new x and new y will follow along, and that will be set as 1. So I'm saying that, okay, marking as visited. That's it. I think so. Once that is done, we are kind of good to go out and return max time. But again, there is a little catch here. The catch here is that I cannot simply go about returning the max time, which is being computed from here. The reason is because this test case, right? The second test case, we could also have a rotten orange, which is separated from all the other oranges, right? So that will never, I mean, we have a fresh orange, which is separated from all the oranges. So we cannot rotten it at any point of a time, right? So I have to check for that. And the easiest way to check for that is uh, comparing that. Let's say what I'll do is I'll say that, okay, look through the grid and check if all the rotten oranges are visited, are probably marked as visited, right? So in this case, the idea would be very simple. For I in range n, followed by for j in range m, I would probably go about saying that if the value in the grid at I and j is equivalent to 1, or the value in the grid at I and j is equivalent to 2. Now notice carefully, why am I ideally you might be thinking, okay, I should check for only the rotten oranges, right? No, the thing is that I have to check for ones as well, because notice carefully, I'm not changing the grid values. After the entire operation has been performed, the grid still has one and twos, bunch of ones and twos. What I am doing is I'm manipulating an algorithm which kind of converts those 1 to 2s, right, using this queue. But actually in the grid, the value is still 1. So assuming that, hey, this was converted to 2s, right? So in that case, I can again say here that, okay, so in this case, I will be having something like this. And if the current cell visited of ij is equal to 0, which means, hey, this was not visited. In that case, I can probably simply return a value which is -1. That's it. And end of the day, if this never gets encountered, then definitely all of them have been rotten, and I can probably return my max time. So yeah, this is what the algorithm would look like.
One minute. Can you open up the lead code, the rotten oranges question, and just directly run this particular on that?
Okay. This one, right?
Yeah.
Yeah. So I'll copy it from here, or should I
Yeah.
write it?
Yeah, yeah, copy. You will be
Okay.
writing
So
everything again.
so I'll just go here, and it might take a little bit of time to readjust this thing. So I'll just look here and see if there's anything which needs
Better
readjustment.
if writing it again takes less time.
Um, yeah, I can probably write it again, but I think so it should be done in a moment. So if you just give me 1 minute and it will be done. So I just need to align a couple of things here. Just give a tab or say space. No, that's not gonna do. Okay, can do it manually. That will be much easier for me. Yeah, that's fine. I have to realign this and this. So it might give me an error like Python indentation problem, but yeah, if that's the problem, then I can again
So
look
if
through it
now
and
it is not showing those pink marks, then it won't, but it can
okay,
take time for
I hope so.
this sort of thing.
Yeah, I really hope so. That's something that should happen. Return max time. Yeah, so can I run this for
Yeah,
just safety measure?
yeah,
Okay.
yeah, you can do.
Mm, the expected 4, but my output was a -1. So is this like the same problem or am I looking at another
Yeah,
one?
it is same problem.
The same? Okay. Mm, okay. So we have this test case here, right? And all of them have been visited. Hmm, sweet. IJ is 1. Okay. Okay. The thing here is that I have not imported that. So I know this won't be any problem. But
Collection.
let's see.
Hmm.
This won't be really a problem. Collections import DQ. So visited has been populated. The name is grid itself, right? Yeah. MS grid of 0, Q is DQ. I'm just doing a little quick recap. So we are going here, and then I'm saying if it's rotten orange, then add it here. And I'm also saying, hey, it's visited. Max time is 0. Directions is initialized as follows. That's sweet. While Q, X, and Y, current minute. Great. Max time is going to be the maximum of my current minute and max time, I guess. Yes. Hmm. Can probably move that as well. It's fine. It's not a thing to be worried about. So for I in range 4, directions, this, okay. Mm, no, that is fine, right? Yeah. New Y is this, new X is this. Now I'm checking if it's inbound. If that's the case, great. Then I'm saying, okay, if it's not visited and the grid of that value is 1, right? Yeah. Then in that case, I'm appending new X, new Y, and current minute plus 1. But also I'm saying that, hey, in the visited, mark it as like simply mark it as visited. Sweet. For I in range this. So I'm saying if grid of ij is equivalent to 1 or this, right? So this input is an integer, right? Yeah, it's an integer. It's not a string. So I thought this was like, I thought this was like 1 or something, but no, it's 1 itself. So if grid of ij is equivalent to 1, and then, okay. So I'll have to have a bracket here, which I think so will probably solve the pain for me. Yeah. So I'll just quickly submit it. Mm, yeah, it's working fine.
Okay. And regarding the time complexity and space complexity, could you explain it again?
Yes, time complexity, as we can see, probably it's going to be big O of 3m cross n. Yeah, 3m cross n, because 1m cross n I can see is in this segment. 1m cross n I can see is while I'm accessing and doing stuff with the queue. And third m cross n I can see is in this segment, right? So in the worst case, time complexity would be, um, I can probably say here my time would be a big O of 3 cross m cross n. Yeah, so this is what my time complexity would look like. Again, since I'm not manipulating the grid, notice I'm not changing the grid, right? So I'm not changing the grid itself. So that's why I'm making use of the visited array or visited matrix. Uh, and hence, that visited matrix is going to account for an m cross n space as well. So if I had to change the grid, the time would be the space would be big of one itself.
Yeah, but we are not required to change it, so it's all right.
Yep.
Okay, yeah,
Yeah.
and the time left. Okay, it's done for this. So any questions from your side?
No, no. The only thing I had in my mind is, um, generally, like you have been working in Dell for quite a long time, right? So what do you have your ideology as? Like in this case, as I mentioned, like I am not allowed to change the grid, right? So what's your thought process on this? Should I change it, or should I like make use of this visited? Because if I change the grid, what my thought process is, that later on I cannot use it for anything else, right? So what's your thought process on this? I just wanted to know that.
Basically, if you would have changed this grid, then I think it won't have made much sense. But in some means, sometime it is not required, as you had mentioned that we can't modify it on later, means we can't use it for any other
Hmm.
cases.
Use case.
So
Yeah.
that's why it's all right to go ahead with the same.
Okay.
Okay then, so this was all for today, and
Yeah.
yeah, just ending
Thank you
this.
for,
Mm,
yeah. Thank you for the interview. Yeah.
yeah, and thank you for your time as well.
Yeah.